Hello friends, now the next topic in active filters is band reject filter. We have two types of band reject filters. One is called wide band reject filter, which has Q factor less than 10, and another is narrow band filter, which has Q factor greater than 10. Remember, there is no clear-cut boundary between a narrow band and wide band filter. Just a limitation or a limit which is put is this: when Q is less than 10, we call the filter as narrow band or wide band, and when Q factor, that is quality factor, is more than 10, we call that as the narrow band filter, right? So to implement, or you can say, wide band reject filter can be implemented by using the simple non-inverting low pass filter, first order low pass filter, and non-inverting first order high pass filter by connecting in at the input of a simple adding circuit. This is a simple adder. We have adder circuit here. So at the input of adder circuit, what do? At one input we connect a low pass filter, at another input we connect high pass filter, and both inputs are connected to the input, or input is given to both low pass stage as well as high pass stage, and output of these two filters is connected at the inputs of a summing amplifier which is connected in inverting mode, right? Now see the careful observation in case of transfer function of this filter. Suppose this is magnitude of the transfer function of, let us see the frequency response for this type of filter. I have low pass filter. So low pass filter allows what? A low pass filter passes through the frequencies above certain critical frequency called lower cutoff frequency. So what I do, through the low pass filter, or low pass filter will filter out the frequencies above certain frequency. Say this is the gain, which is nothing but A0, and that A0 is nothing but RF by R1, I can say, right? This is what I have. Now what I do, I have output of this. This is the output of low pass stage. Low pass stage will be allowing or passing the what? It will be passing certain band of frequencies like this. So it passes through, or it allows the frequencies above certain frequency called lower cutoff frequency of the filter. Similarly, what I do, I select high pass filter. I'm sorry. This filter is nothing but not low pass. There is a little correction, please. This is the characteristic of high pass filter, which allows to pass through the frequency above certain frequency, and this is the cutoff frequency of high pass filter, lowest cutoff frequency of high pass filter. So high pass filter stage, this stage is selected such that it allows to pass the frequencies above certain cutoff frequency. This is gain, which is constant gain A0, and this is A0 by root 2, right? Now I select the cutoff frequencies of, this is low pass, this is high pass. So this characteristic belong to this filter, this stage, this, which is high pass. Now I select the characteristic of that filter such that it passes through, or it allows the frequencies up to certain frequency, which is called cutoff frequency of the low pass stage, which is highest frequency of low pass, right? So that means if I select this filter, now try to recall, this is high pass filter. The cutoff frequency of high pass filter is nothing but 1 by 2 pi R2C2. The cutoff frequency of this is FL, that is cutoff frequency of high pass is FL 1 by 2 pi R2C2, right? What is cutoff frequency of this? The cutoff frequency of low pass stage is 1 by 2 pi R1C1. How I am writing this? You can refer my video on low pass filter and high pass filter, right? So these are the two cutoff frequencies. If I select the lowest cutoff frequency of high pass stage, more than the highest cutoff frequency of low pass stage, this is selected, the cutoff frequency of high pass stage is selected to be more than the cutoff frequency of low pass stage, then there will be a band which is rejected. This band where gain is less than A0 by root 2 is called rejected band. This is what? Rejected band. So it will be rejecting this band. So the bandwidth which is being rejected is what? Bandwidth which is being rejected is what? FL minus FH, right? So it will be rejecting the frequencies from FH to FL, where gain of the filter is less than A0 by root 2. That means I can implement a band reject filter by using a low pass stage, a high pass stage, both connecting at the input of simple inverting amplifier with gain of unity, R by R. With respect to this, gain will be R by R means what? 1. With respect to this, maybe this is B02, gain is again R by R, that is 1, right? So this is how we can implement a wide band reject filter using low pass filter and high pass filter. That gives me the desired frequency response. So by selecting suitable values of FL and FH, or by selecting suitable values of R1 and C1 and R2 and C2, I can decide the values of the cutoff frequencies, that is FL and FH, and accordingly I can decide the band of the frequency to be rejected. Now, if what I do, if I select, so condition is what? Condition for this to be band reject filter is FL should be greater than FH. FL should be greater than FH, only then it will be rejecting. What will happen if I select FL less than FH? What will happen if this becomes less? So it means if FL is, suppose this is FH, this is FL. So what will happen? You please see carefully. This will attenuate the frequencies up to here. It will allow to pass above this, and this will attenuate the frequencies below this. It means gain is not reducing throughout for any frequency. Gain remains constant throughout. It means all the frequencies which are there at the input will be reaching at the input if FL is less than FH. So for this circuit to behave like band reject filter, FL should be greater than FH, that is this condition. I hope concept is clear. So that is how I can use a low pass filter and high pass filter for rejecting certain band of frequency. Similarly, by connecting a low pass filter and high pass filter in a cascade, you can see my video on wide band pass filter. By connecting these two filters in a cascade, I can implement wide band pass filter, right? So this is your wide band reject filter, which can be implemented by using a low pass filter and high pass filter, both connected at input of a summing amplifier which is having unity gain with respect to each input, and input to both stages is given to be same, right? I hope the concept is clear. And for this type of filter, Q factor is normally kept more than, or sorry, less than 10. Now, how to implement narrow band reject filter? A narrow band reject filter can also be implemented by using what? By using simple R and C elements, right? So R and C, resistance and capacitor, and that circuit is called notch filter. What is that circuit? That circuit is 20. By using 20 network, we can implement by using twin T network, we can implement a narrow band reject filter. Let us see what is twin T network. A twin T network is like this. We have two resistances and a capacitor like this, right? This is called T network. That circuit is called T network. This is R, this is R, this is likely to be 2C. Then I have another T, this is T, right? I have another T where I have C, capacitance C like this, capacitance C like this, right? And there is a resistance connected here, right? And this is connected here like this. This is C, this is C, this is R by 2. These are the elements. This is how we select these values, right? And input is given to this terminal Vin, and this is grounded, and output of this is called twin T network. That is called twin T network. This network is a notch filter. Notch filter means it rejects a very narrow band of frequency or almost one single frequency, right? And output of this filter is connected to a circuit which is called voltage follower or unity gain amplifier. This is what? Voltage follower, right? So output of the notch, this is twin T filter, and this combined is called narrow band reject filter. You can analyze, but analysis is not required. That's not that much important. Important is basically its circuit or function performed by the circuit. Now, what is the function? Voltage follower circuit is basically used to provide isolation. What is the meaning of isolation? It provides very high impedance on the input side and very low impedance on the output side. So high impedance this side is matched with the low impedance on that side. So that's why we call this as impedance matching, right? And it has unity voltage gain. Now let us talk about the characteristic. So this is gain of the filter, magnitude, this is frequency. So this filter rejects a very narrow band of frequency like this, just like previous case, right? So it simply rejects narrow band, and that frequency at which this bottom, this narrow this is getting narrowed is called notch frequency. And say this is constant gain A0, this is A0 by root 2. The frequency at which the gain falls to A0 by root 2, this is highest cutoff frequency of lower stage, this is lowest frequency of next stage, right? And this is called bandwidth of the filter, right? Now the bandwidth of this filter is equal to FL minus FH, right? And there is something called quality factor for this network. The quality factor for this network is known as Fn by FL minus FH, or that is Fn by bandwidth. This is called quality factor of notch filter, where Fn is called notch frequency of the filter, right? So Fn is the frequency at which the amplitude of gain or magnitude of gain is lowest, minimal. That is called notch frequency. So you just need to remember the name of the circuit, or you need to remember this circuit, that is known as twin T circuit followed by unity follower, which is called narrow band filter, or sometimes it is called notch filter, right? I hope you will remember this circuit. You don't need to go for mathematical analysis because you don't have any question on these type of circuits. That is just for sake of coverage. So that is not very important from examination point of view. You had questions nowhere in an exam, but at least you should know the circuit and its function performed by the circuit. So I hope this concept is clear, and that completes your band reject filters. So in next video I'll be talking about next filter, that is all pass filter. Thank you very much for watching the video.